right, fractions, your favorite. I know it. Dividing fractions. So think back to sixth grade and maybe a little bit of fifth grade when you started to explore the meaning of dividing fractional parts up. So the first quantity in any problem doesn't change because if it's a word problem, it's just whatever you start with. So for example, like 5/6, ignore the negative. Maybe you had 5/6 of a pan of brownies. Like it's a fact, you don't change it. So the first amount will not change. But then we realized with drawing the meaning out visually that dividing fractions is the same as multiplying by the reciprocal. And again, the reason why this works is because division and multiplication are so interconnected. Over to the upper right, I have a chart showing you what reciprocal means. It's just a number that when you multiply it by another number, you get a product of 1. 2, the reciprocal is 1/2, right? Because we would write the number 2 over 1, right? 2 wholes. The reciprocal would be 1/2, because if we flip those around and we multiplied across, we would get 1. 2/3. The reciprocal is 3/2, because again, if we multiplied these, we would get 1 whole. Same with 4/5, turns to 5/4. 1 1/5 is the same as 6/5. If we multiplied that by 5/6, we would get 1. Okay, so just know that the reciprocal is, just flipping it around so that we get a product of 1. Back to our problem, 5/6 is what we start with. And then step 2, multiply by the reciprocal of the divisor. And the divisor is what you're dividing it up by. The reciprocal of 1/4 is 4 over 1. So here we have changed it to a multiplication problem because, again, doing it this way, it's the same. And now we can apply our multiplication steps from last week to finish out this problem. So we would multiply the numerators, multiply the denominators, and remember our rules for a negative being divided by a positive or a negative times a positive. The rules are the same. We would get a negative result. We can put it with the 20. We can put it with the 6 out in front. Any way, it means the same thing. And now if we want, we can take this negative 26 and turn it into a mixed number by using division, because that's what the fraction bar means. 6 goes into 20 3 whole times, because that would be 18. And 18 would mean that we have 2 left over because we wanted 20. And then denominator still stays the same because its pieces are the same size. I could even simplify this further and call this 1/3 instead of 2/6. And then I'm always going to ask myself, does my answer make sense? Back to the original problem, I'm asking myself, like, how many times does 1/4 go into 5/6? Well, 5/6 is almost a whole. 1/4 is smaller. So saying it goes in about 3 1/3 time, it makes sense to me. There's about 3 groups that would fit in a little bit more. Okay. All right. So next one. Story problem. If a piece of wood is 2.5 feet in length and you cut it into 1/3 foot size pieces, how many pieces can be made? Okay, so I'm already starting to kind of estimate in my mind. It's like saying how many 1/3 would fit into our total of 2.5 to begin with. I'm going to expect a large amount. Like there's a decent amount that could fit. My number should be definitely more than 1, more than 2. Okay. So let's apply the rules. 2.5 is the same as 5/2. I turned it to an improper fraction. I'm going to multiply by the reciprocal of 1/3, which is 3 over 1. And now I will multiply across. 5 times 3 is 15. 2 times 1 is 2. 15/2 is the same as 2 goes into 15 7 whole times because that would be 14, and then 1 piece left over. The size of the pieces are still halves. So 7.5 pieces can be made. And again, that makes sense to me because I expected it to be a decent amount. All right, and then a positive divided by a positive just stays a positive. And in the context of this story problem, like we would have 7.5 pieces. It wouldn't make sense to call it negative 7.5 pieces. All right, and so that's how we divide fractions.